Hello, welcome to this lesson on the uses of radioactive isotopes or radioisotopes. And the question of the day, what is a radioisotope? A radioisotope is just an isotope of an element that happens to be radioactive. And a lot of the time we think of that as something super dangerous and something we should never, ever, ever touch. But there are a few that have some practical uses for us that are actually really helpful. One of the ways we can use radioisotopes is as a medical tracer. And really, what this means is that we are going to, in some way, get a radioisotope inside of somebody's body. Sometimes they eat it, sometimes it is injected, sometimes you drink it, sometimes it's a medicine, it's a pill, but any which way, it's going to get inside of a person's body. And the idea is that this tracer is going to find its way to a specific part of the body. When you consume calcium, it goes to your bones to build your bones. When you have proteins, for instance, which contain a lot of nitrogen and phosphorus, those are going to go into the muscles in your body. So depending on the type of tracer, it'll go to different parts of the body. And then a specific type of medical scan is going to be used to find this medical tracer. So I don't know if it could be an X-ray. I know that primarily they're going to be read on MRIs and CAT scans. Here you can see a kidney. This is a kidney. It has all of its structures kind of shown here because of the use of contrast, which is a dye, which could be used instead. A contrast may have a radioisotope and it may not. It's still a medical tracer, so I thought it was good to put it in here. But we can also use tracers in chemical reactions, which is where you may see them more so in high school chemistry. Not that you would use them, but in concept. Let's say we're keeping an eye on a reaction that includes water. One of those waters may have a deuterium in place of a hydrogen. So that's just a hydrogen with a mass number of 2, and like deuterium. And that is going to be a little bit heavier than all of the other hydrogens that are present in the water sample. So it'll be easy to find in a scan, really, to see where that specific hydrogen is going. And that's the idea that we would use it for chemical reactions. Now, getting into some specifics. Iodine 131 is going to be used to diagnose or treat thyroid disorders. So, the thyroid is a butterfly shaped gland in the neck, and it helps to regulate sleep and metabolism. And there are actually a good number of people who have thyroid issues. So, in order to diagnose them or maybe even treat them, iodine 131 is going to be used to help these people get their things figured out. You may remember carbon-14 back from learning like earth science or geology, and we use carbon-14 to figure out how long ago something died. It's usually used for like dinosaurs, maybe some really old trees. The idea is that every living being has carbon in it, and we all are going to have some amount of carbon-14 somewhere in our bodies just because of chance. It's just the way that it happens. So if you find that carbon-14, then you can find, based on the half-life, how far back in the past this carbon-14 was carbon-14 on its path to degradation down in the half-lives as it is emitting particles. So using that half-life number, or the number of years it takes for half of the sample to degrade, then you can figure out how long ago this thing had its full amount of carbon-14. The half-life of carbon-14 is over 5,000 years, so it can't be used on things that are dead within that 5,000 years, really. It's going to be things that are like a lot of thousands of years old. Then we have uranium-238, and this can be used to date rocks. We know that rocks are really, really, really old. Some of them are younger than others, but for the most part, they're very old. But the uranium-238 is going to be not used, but it's going to be found in nearly all geological formations just because they're so big. Think of like valleys and canyons and mountain ranges, plateaus, those big things. Not necessarily like a little rock that you just find in your backyard. So the uranium-238, the same way the carbon-14, it's going to kind of be backdated to figure out when that rock formed, because once a rock forms, it doesn't really change all that much. I mean, it may erode, but the composition of the rock is not going to change all that much. So doing that, they can figure out how long ago a mountain range formed, or perhaps a valley carved out by a river. I don't know why I just blanked on the word river. But yeah, the uranium-238 is going to be used to date really, really old rocks. This could even be used to date the sea floor, and really what's done is the ratio of the uranium-238 to lead-206 is going to be measured, because that uranium-238, of course, is going to degrade over time. So the more lead-206 you have and the less uranium, the older it's going to be. Cobalt-60 can be used to treat some types of cancer. At this point, I'm not so sure anymore, just because the field of cancer research is very changing. It hasn't changed, but it also has changed quite a bit. So again, I don't know specifically what types. I think that would be a really cool thing for you to look into if it was something that was interesting to you. But it's cobalt-60. It can be used to treat some types of cancer. Then we have americium-241, and this is used in the smoke detector in your own house. So the smoke detector is going to release alpha particles. The radioisotope, that is going to release alpha particles, and they're going to flow through the detector. So remember, alpha particles are positive. So they're going to flow away from a positive part of your smoke detector down to a negative piece, and that's just an electric field produced by the battery. And if there is smoke from this fire, it will disrupt the flow of those alpha particles. And once that flow is broken, the smoke detector is going to go off. That's why if there's a battery in your smoke detector and the battery is dying, then the flow is not going to be detected very well, because that positive and negative isn't really there because the battery is dying. So in that case, your battery will, or your smoke detector rather, will chirp to let you know, hey, the flow is disrupted here. It's usually like a nice, not nice, but it's a calm chirping. And when you have smoke in the house, it's like a really big chirping. But that is how smoke detectors work with americium-241. There are plenty of other radioisotopes that have practical uses, but these are just a few that come up pretty often. So I thought it would be good to share them with you. All right. If you have any questions, of course, please leave them in the comment section below the video. Subscribe so you don't miss the next lesson, and I'll see you there. Bye.